Hello and welcome to CUDA Weekly. I'm your host Johan Bontes. Today I want to talk about timing your GPU code. The reason that we're programming on GPUs is of course that we want to write fast code, faster than the GPU. But how will we know what code runs slower and which one runs faster? Let's talk about it. Let's say we want to time some code on the GPU. We can do this very accurate up to the clock cycle using relatively simple code. So the first thing we need to do is to add some code to actually do the timing. When we do this, we can see that taking the time itself is a really fast process with only 2 cycles of overhead, except on the first run. This is the reason why we always want to do more than one run, because there might be spikes or there might be other startup costs that we don't want to include in our timings. So if we add a little bit of code here, we can see that the time, if we add some code here, we can see that the time changes and that after some initial problems, 8, 411, we settle on a time of 12 minus the 2 for the time. So that means our instruction here takes about 10 clock cycles, which is fairly typical. Now you can see that this instruction here, where are we, translate directly to a single instruction. One of the nice things about having a really accurate cycle timer is that you can experiment and see the effect of certain optimizations that the compiler does. Here we can see that this loop is being unrolled by the fact that our shuffle instructions occurs a couple of times in the actual output code. Now we have PTX, but that's not, it's more of a virtual machine code, just like the Java bytecode. The actual assembly that the GPU outputs is called shader assembler, SASS. There we can see that the shuffle instructions is run a number of times, matching up with the loop unrolling that's actually taking place. Now, if we remove the unrolling by forcing the unrolling to just run once, then we can see that our time increases quite a lot, up to 21. Now, the reason for this is that no longer does it inline this thing in 10 consecutive sections, but it does a couple of jumps. So it wraps this thing in a call, which now includes the call overhead. So we can see that the compiler does a fair amount of work optimizing our code, and this really makes a difference in the final timings. It's generally a good idea to leave these optimizations in place. Settings. Okay, I would like to leave it here. Thank you for watching, and we'll see you again next week.